Hello, hello. We're going to be having some time doing a reteaching video. So if you're unsure how to do a problem on the reteaching, these are similar problems to the reteaching, which are also similar problems to the quizzes, which are also similar problems to the tests. Okay, first comes first. I'm looking here, I see first that they are all multiplying. All these things are being multiplied. So I have to think in my head, if I'm multiplying, what should I be doing with the exponents? I should be adding them. Again, think of arithmetic. If it's multiplying, the other positive type of arithmetic is adding. So first I look at the 5 and the 6. I can't do anything with those numbers. I can multiply them together though. So I'm going to have 30. Now I have my x's. They have the same base. My x's on the same base. I'm looking at my exponents. I'm going to be adding those together. So I have my x, that's the base, that's the same. And I add the exponents. So 7 plus 0 is 7. Now I look at my y's, and again I'm still multiplying. So if I'm multiplying, I'm adding my exponents. So I have 4 plus 3 is 7. And then I look at my base of z's. These have the same base. So I write my z, and I add my exponents. 2 plus 8 is 10, and this is my final answer. Next. Whoa. So I'm going to simplify this. When I'm looking at this problem, it says, it's a little crooked. I have a power to a power. So this power is on the outside. Power to a power. I think, what should I be doing with my exponent? Power to a power. I should be, what is it again? Multiplying. Remember, don't be greedy. Give it to everyone on the inside, everyone. So this 7 is raised to the first power. So power to a power, I multiply. Power to a power, I multiply. So I have 7 to the 9th, because 1 times 9 is 7. And I have a, that 9 times 5 is 45. And then I have my base b, and then 9 times 7 is 63. And that would be my final answer. Next. Remember when you're doing these problems, especially for question number 4 too, there's different orders that you can simplify these. So I could do things differently, but we could still come up with the same answer. So I'm looking at this problem, it's division. I don't see any negative numbers, so I'm going to just start simplifying. So I personally always draw my division bar, and I take it one step at a time. So I look at my whole numbers here, my 8 and my 12. So since I don't have any fraction exponents, I'm not going to write in prime factorization. That's when you have a fraction exponent that you want to see if it can simplify further. In this case, I don't. 12 over 8, what do both of those get divided by? What factor goes into both of those? 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So now I look at my a's because those have the same base. Remember, if there's no number, it's always raised to the first. So you could either do the top, subtract the bottom, and then move accordingly. Again, I personally like to look at my a's. There are more a's on bottom, so I'm going to write my a on bottom. And once I know if it's on top or bottom, then I always subtract. With division, if I'm dividing with the same base, I subtract my exponent. So 9 subtract 1 is 8. Now I look at my b's. My b's have the same base. So again, my thinking process first is, are there more b's on top or bottom? Well, there's more b's on bottom, so my b's will end up on bottom. And then I always take my larger one minus my smaller one. Once I do that first step, are there more on top or bottom? I always take my larger minus my smaller, and 5 minus 3 is 2. And finally, I'm looking at my c's. When I look at my c's here, they're the exact same thing. So if they're the exact same thing, they will completely cancel each other out. Because just like how 5 over 5 is equal to 1, c to the 7th over c to the 7th, if it's the exact same thing, it's 1. And b multiplied by 1 is just kind of, you don't have to have it. So that's that answer. Last one for 6.4a. When I do this, I always first, me personally, I like to simplify with my negative exponents first. So I'm not going to do anything else So these both have a positive 1 exponent. Remember, if there's nothing there, it's a positive 1. Now I'm going to go through each one and think, should I change it or not? So when I'm looking at this x has a negative 3 exponent, so I'm going to move that to the bottom. Because if it's negative on top, it will be positive on bottom. This x, this is already positive, so it's going to stay on bottom. Looking at my y's, this y is positive, so it's going to stay on top. This y is positive, so it's going to stay on bottom. Looking at my z's, this z is negative, so it's going to move to the bottom. This z is negative, so it's going to move to the top. And now once I do that, now I can simplify with the bases. Again, the 3 and 24, there is no fraction exponent with this, so I can think, can I divide 3 and 24 by a number? Well, by golly, I can. Both 3 and 24 can be divisible by 3. So 3 divided by 3 is 1. 24 divided by 3 is 8. Now I'm going to look at my x's. Now when I look at my x's, they're both on bottom. If they're both on bottom, that means they're being multiplied together. So they're going to stay on bottom because they're both on bottom. And I have to think, if I multiply them with the same base, what should I be doing with my exponents? Well, they should be adding together. And I look at my y's. My y's, one's on top and one's on bottom. So when I'm looking at this, there's more on bottom, so my y's will end up on bottom. And I always take my larger, subtract my smaller. So 8 minus 5 would give me 3. And finally my z's. I'm dividing, so I first think, are there more on top or bottom? There's more on top. So I always take my larger minus my smaller, which would be 3. And this would be my final answer. So this is reteaching similar problems for 6.4a.